Welcome to the next session, my dear friends. So in the previous session we have discussed up to the question number 26. So let us start our discussion of the previous gate questions. So next question is question number 27. Question number 27, it is gate 2008 2 marks question. Gate 2008 2 marks question. Question number 27. Okay, let us read out the question. It was match the following. List 1 is estimation method and list 2 is corresponding indicator. Okay, list 1 is estimation method and list 2 is corresponding indicator. So first one is azide modified Winkler's method for dissolved oxygen. Azide modified Winkler's method for DO, method for dissolved oxygen. This is first one. Next one is dichromate method for chemical oxygen demand. Dichromate method for chemical oxygen demand. And option C, EDTA titrimetric method for hardness. EDTA method for hardness. And Moore or argentometric method for chlorides. Method for chlorides. So these are the 4 methods given, estimation methods, and in the list 2 the indicators are given, and list 2 indicators. So first one is Erythrome black tea. First one is Erythrome black tea. And the second one is ferroin. And third one is potassium chromate, and last one is starch. And last one is starch. So here we know that already. So EDTA method, some of the indicators we know very strongly. That is, first one is EDTA method. So EDTA method we use EBT, Erythrome black tea. Here EDTA method we use Erythrome black tea, that we know. Okay, already we have discussed this. And here for Winkler's method, the indicator is starch. We know this also. We know this also. And here Mohr method. For Mohr method we use potassium chromate as indicator. These three we already discussed. So this chemical oxygen demand we haven't discussed yet. Okay, so this will come in sewage treatment. Okay, now this is ferroion is indicator, anyways it came here. So this is an indicator which we use which we used for the endpoint indicator of chemical oxygen demand. This thing we will discuss in detail during the discussion of sewage treatment. Okay, so rest of the things we already discussed. So accordingly also we can choose the answer, because if you know 3, obviously the fourth one is left for the last one. Okay, so this is question number 27. Let us go to the next question, question number 28. Question number 28 and 29 is a common data question. 28, 29 common data question, 2009, 4 marks. Twenty-eight, 29, 2009. Two marks. So the chemical species, following chemical species were reported for water sample from a well. So they have taken a well water and they did chemical analysis, and the following species are found. Okay, so what is the species? So given data, species and its concentration. Concentration in milli equivalent per liter. Milli equivalent per liter. Okay, so the concentrations of chlorides chloride Cl minus, how much is the concentration? 15 milli equivalent per liter, 15 chlorides. And next is sulfates SO4 2 minus, it is 15 again. Carbonates CO3 2 minus, it is 0.5, that is 5. And bicarbonate 30. Calcium 12. Magnesium 18. And pH is 8.5. pH is 8.5. So this was the data given. So what he is asking now? He is asking total hardness. Okay, let us see what is total hardness for this. He is asking total hardness. Again, total hardness is caused due to multivalent metallic cations. What are the multivalent metallic cations? These two are the multivalent metallic cations. So total hardness in mg per liter as CaCO3 is equal to Ca2 plus concentration in mg per liter into equivalent weight, that is 50 by 20 plus mg2 plus into 50 by 12. Actually, when the concentration is in milligram per liter, but here the concentrations are given in milli equivalent per liter. The concentrations are given in milli equivalent per liter. So first of all, I need to convert these concentrations from milli equivalent per liter to mg per liter. Okay, so let us see how to convert that. X mg per liter is equal to, when X is in milli equivalent per liter, milli equivalent per liter into equivalent weight. Okay, into equivalent weight, because already there is milli, so whatever the milli will go here, it will become milligram. So there is no need of multiplying it with 1000. There is no need of multiplying it with 1000. For example, if it is Ca2 plus, if I want Ca2 plus in milligram per liter, if I want Ca2 plus in milligram per liter, then Ca2 plus milli equivalent per liter, milli equivalent per liter multiplied with equivalent weight of Ca2 plus, equivalent weight of Ca2 plus. So bring this here, bring this here. So that means total hardness is equal to, so this is for Ca2 plus, Ca2 plus in milli equivalent per liter into equivalent weight of Ca2 plus. So this is the concentration of Ca2 plus in mg per liter. This is the concentration of Ca2 plus in mg per liter. Ca2 plus in milli equivalent, because I have replaced this with this statement, that's it. Multiplied with equivalent weight of CaCO3 by equivalent weight of Ca2 plus, equivalent weight of Ca2 plus. So this already we know, this is the formula. So instead of Ca2 plus, I am keeping this, and this is equivalent weight of CaCO3 and this is equivalent weight of Ca2 plus. That means here equivalent weight of Ca2 plus and equivalent weight of Ca2 plus is cancelled. That means when the data is given in milli equivalent, when the data is given in milli equivalent, then you can directly multiply, this milli equivalent with the equivalent weight of CaCO3, with the equivalent weight of CaCO3, because this equivalent weight of that compound will get cancelled by this value, So here we take equivalent weight of X. So here also we are taking equivalent weight of X and X get cancelled. So that is why when the concentration is given in milli equivalent, the calculation will be much more simpler. And the concentrations are given in milli equivalents, then total hardness is and the concentrations are given in milli equivalents, then total hardness is equal to Ca2 plus in milli equivalent per liter multiplied with total hardness as CaCO3. Total hardness in mg per liter as CaCO3 is equal to Ca2 plus in milli equivalent per liter into equivalent weight of CaCO3 plus Mg2 plus milli equivalent per liter into equivalent weight of CaCO3. So that means if I take equivalent weight of CaCO3 as common, that means total hardness in mg per liter as CaCO3 is equal to Ca2 plus milli equivalent per liter plus Mg2 plus milli equivalent per liter, because equivalent weight of CaCO3 can be taken as common, so which is equal to 50. So simple, add all the milli equivalents and multiply at last with 50, that will be the answer. So here also total hardness is nothing but Ca2 plus is how much? Ca2 plus is 12, magnesium is 18, how much? 12 plus 18, that is 30. 30 into 50, that is simple, 30 into 50 is the answer. No need to do much calculations when it is given in milli equivalent per liter. So because in milli equivalent liter if given, then you can directly multiply it with 50, then that is, you can add all the things. So what are the multivalent cations concentrations? You can add all the concentration and simply multiply it with 50 at last. That will be the total hardness value when it is given in milli equivalent per liter. Especially when it is given in milli equivalent per liter, then it is very easy to solve. You can directly add all the concentrations and at last you can multiply it with 50. That is equivalent weight of CaCO3. Okay. Now this is total hardness. This is the first question. 150 is the answer. 150 is the answer. Sorry, that is 1500, not 150, because 5 3s are 15 and 2 zeros are there. So 1500. 1500 mg per liter is the hardness as CaCO3. And what is the next question? What is the next question? Question number 29. Alkalinity present in the water as CaCO3. Alkalinity. So alkalinity is caused because of negatively charged ions, but predominantly it is due to these two, CO3 2 minus and CO3 minus. Okay, predominantly it is due to these two. So what is that alkalinity? Total alkalinity. Total alkalinity. Total alkalinity in mg per liter as CaCO3, which is equal to, as CaCO3 which is equal to, sum it up, 35. 35 into 50 is the answer. 35 multiplied with 50. So 35 5s, 15, 1750. So it is 1750. It is 1750. 1750 is the answer. So this is the total alkalinity, that is total hardness. Okay. So 28th question it is 1500 and 29th question it is 1750. So let us go to the next question, question number 30 and 31. It is again a common data question given in 2010. So every year 4 marks approximately it is coming from this topic. 29 and 30. Sorry, 29 was already taken. This was 29th question. This is 29th. So this is 29th question. Alkalinity is nothing but 29. So now 29th question is over. This is 29th question. This is 28th question. So let us go to the next question, 30th and 31. Question number 30 and 31. 2010, 2 marks question. So let us read out the question. Ion concentrations obtained for groundwater sample, same question, having pH of 8.1 are given below. So ion concentrations are given, atomic weights are given. So what is the total hardness? Total hardness, okay. Okay. So ion concentration, in mg per liter. So for calcium 2 plus, for calcium it is 100, and for magnesium it is 6, for sodium it is 15, and HCO3 minus 250, SO4 2 minus, that is 45, Cl minus, that is 39. So total hardness, and second question is carbonate hardness. So first question is total hardness. So total hardness here, total hardness is equal to Ca2 plus in mg per liter into 50 by 20 plus mg2 plus, because multivalent cations there are 2 only, mg2 plus into 50 by 12. So Ca2 plus concentration is 100 mg per liter into 50 by 20 in mg per liter as CaCO3 plus mg2 plus is 6 into 50 by 12, which is equal to 250 plus 25. 250 plus 25, that is 275 mg per liter as CaCO3. This is total hardness. This is total hardness. So now this is the 30th question. So question number 31. So 275 is the total hardness value. Question number 31 is carbonate hardness. So what is carbonate hardness? Carbonate hardness. So carbonate hardness is equal to minimum of alkalinity and hardness. So we have determined hardness. So let us determine alkalinity. So alkalinity in mg per liter as CaCO3 is equal to CO3 2 minus concentration mg per liter into 50 by 30 plus HCO3 minus concentration in mg per liter into 50 by 61. Here if you see CO3 2 minus is not there, only HCO3 minus is not there, only HCO3 minus is present, so this is 0. So this value is how much? 250. That means it is equal to 250 into 50 by 61. 250 into 50 by 61. If you do this, then you will get a value of 205 mg per liter. 205 mg per liter. So the carbonate hardness is minimum. This is 205 and this is 275. That means it is equal to 205. So carbonate hardness is equal to how much? The carbonate hardness is equal to 205 mg per liter as CaCO3. carbonate hardness is equal to 205 mg per liter as CaCO3. This is question number 31. This is question number 31. See, question number 32. Question number 32 is not relevant to this topic. It is actually that question should be taken up in disinfection topic. So we will discuss this question number 32 in disinfection. Okay, so 17 and 18 is from alum and question number 32 is from disinfection. So we will discuss this question there. So let us go to the question number 33. Question number 33, 2012 GATE 2 marks question. Question number 33. (2012) 2 marks question. Okay, see here. A water sample has a pH of 9.25. The concentration of hydroxyl ions in the water sample is. So pH is given. So what is the given data here? Given that the pH is 10 to the power of pH is 9.25. pH is 9.25. He is asking what is the OH minus ion concentration. What is the OH minus ion concentration? So if this is pH, then POH is equal to how much? 14 minus 9.25. That is equal to 13 minus 9. It is 4.75. It is 4.75. So this is POH. So POH is equal to minus log of OH minus ion concentration. So that means OH minus ion concentration is equal to 10 to the power of minus 4.75 mole per liter. 10 to the power of minus 4.75 mole per liter, not millimoles. It is mole per liter. So, or else directly if you solve it, you will get the value. So if you solve it, then you will get a value of, see here the answer is in milligram per liter. So some values are in milligram per liter. So we need to convert this mole per liter into milligram per liter. Let us convert this. So 10 to the power of minus 4.75 mole per liter OH minus ion in mg per liter is equal to, so this is the concentration in mole per liter into molecular weight into molecular weight. What is the molecular weight? 17 gram per mole. 17 gram per mole is the molecular weight of OH minus. Oxygen is 16 and hydrogen is 1. 16 plus 1, 17 gram per mole into 1000. If you do this, you will get the answer. If you solve this, you will get the answer as 0.302. You will get the answer of 0.302 mg per liter. 0.302 mg per liter. So simple pH was given. So pH plus POH is equal to 14. pH plus POH is equal to 14. So from here I can find POH, which is equal to 14 minus pH, which is equal to 4.75. So POH is equal to 4.75. That means POH is equal to minus log of OH minus ion concentration. If POH is 4.75, then OH minus ion concentration should be equal to 10 to the power of minus 4.75 mole per liter. But here the answer is not given in mole per liter, answer is given in milligram per liter. So we need to convert this mole per liter into milligram per liter. So x in mole per liter multiplied with molecular weight of x into 1000. So x in mole per liter is 10 to the power of minus 4.75 and the molecular weight. So this is the molecule OH, its molecular weight is 17. So 17 gram per mole. We want to convert this gram into milligram. So that is why I am multiplying it with 1000. So if you solve this equation, you will get it as 0.302 milligram per liter. That is question number 33. Let us go to the next question, question number 34. Question number 34, 2014, 1 mark, set 1. One mark, set 1. Here some of the non-toxic metals normally found in natural water. See, we have discussed what are the different kind of toxic metals and non-toxic metals. So he is asking that what are the different non-toxic metals. Non-toxic metals means the given options are like this. Option A, arsenic. See, arsenic it's a toxic metal, so option A is wrong. Option A is wrong because arsenic, lead and mercury, they are all toxic metals. Okay, so they are all toxic metals, it is wrong. So let us go to the option B, calcium, sodium and silver. Silver again not a toxic metal, silver again a toxic metal, so it is not the answer. Cadmium, chromium is also again toxic metals. So the option D is iron, manganese and magnesium. These are non-toxic metals. Iron, manganese and magnesium. So these are the non-toxic metals that are found in natural water. Okay, that is the answer. Question number 35, GATE 2014 2 marks question. Question number 35. Two marks question, set 1. So what is the data given? So for a sample of water with the ionic composition shown in the figure below, the carbonate and non-carbonate hardness concentrations in mg per liter respectively are. So there was a figure given. Let us see the figure. Ca2 plus, Mg2 plus and sodium. Here this is HCO3 minus and SO4 2 minus. So this is a scale given. So what he is asking is the carbonate and non-carbonate hardness. He is asking to find carbonate hardness and non-carbonate hardness. So if you look at this question first time, you feel that this is a very tough question, but it is very simple question actually. So here it was given like a scale. Okay, this is the cations, these are the anions. So here he is asking first of all hardness, carbonate hardness and non-carbonate hardness. To determine anything, we need alkalinity and total hardness. So first let us find total hardness. Total hardness in mg per liter as CaCO3. See here the data is given in milli equivalent per liter. Here the data is given in the form of milli equivalent per liter. So when any data given in milli equivalent per liter, then what is the formula of the hardness? What is the formula of hardness? So simply Ca2 plus concentration in milli equivalent per liter plus Mg2 plus concentration in milli equivalent per liter into the equivalent weight of CaCO3. Equivalent weight of CaCO3. So this is the formula we have learned. So that means Ca2 plus concentration is how much? 4. This is scale which is having a value of 4. So from 4 to 5 it is Mg2 plus. That means Mg2 plus concentration is 1. So that means you can directly take from here to here. Ca2 plus Mg2 plus is nothing but 5. It is 5. So 5 milli equivalent per liter into 50, that is equal to 150 mg per liter of hardness as CaCO3. So this is the total hardness. Similarly, total alkalinity in the same manner, total alkalinity in mg per liter as CaCO3 is equal to HCO3 minus in milli equivalent per liter plus CO3 2 minus in milli equivalent per liter multiplied with 50. So here CO3 2 minus is not there. So HCO3 is 0 to 3.5. That means 3.5. So 3.5 into 50. Okay. 3.5, it is 250, 55 is a 250. So 150 plus 25, 150 plus 25, that is 175. mg per liter as CaCO3. This is total alkalinity. So carbonate hardness is equal to minimum of alkalinity and hardness. So alkalinity is how much? Alkalinity is 175 and hardness is 250. So that means carbonate hardness is equal to 175 mg per liter as CaCO3 and non-carbonate hardness is equal to total hardness minus carbonate hardness, which is equal to 250 minus 175, which is equal to 75, as CaCO3. So this is 75 and that is 175. So the carbonate hardness, carbonate is 175 and non-carbonate is 75. So the carbonate is 175 and this is 75. The answer should be 175 and 75 because he has asked carbonate hardness first and then he has asked non-carbonate hardness, that is 175 and 75. This is question number 35. Question number 35. So let us go to the next question. Question number 36. GATE 2015 1 mark. GATE 2015 1 mark. So let us read out the question. A groundwater sample was found to contain 500 milligram per liter total dissolved solids. Then total dissolved solids in percentage will be. So TDS. So in a groundwater, TDS was given as 500 mg per liter. TDS is given as 500 mg per liter. Then what is the TDS in percentage? TDS in percentage. See, in percentage means generally 1 liter of water is equal to 1 kg. So 1 liter water weighs 1 kg. Okay. So the concentration here in percentage means 500 milligram by the weight of the water. That is nothing but percentage. So TDS in percentage means 500 milligram by 1 kg. So to maintain uniform units into 100. So this is percentage. To maintain uniform units, so I need to convert this into gram and this also into gram. So 500 in gram means, so that means 500 by 1000. So this is gram now. Multiplied by 1 kg means 1 kg is again 1000 gram. So this is 1000. So gram. So into 100. It is equal to 0.01%. So the value of TDS in percentage, if you want, then it is 0.01. Then it is 0.01. 0.01 or 0.05. It is 5, no? 0.05 percentage. Okay. So this is question number 36, GATE 2015. 1 mark question from set 2. So now we will discuss the rest of the questions. There are 15 questions, 14 more questions are left. So we will discuss all those questions in the next session. Thank you so much.